Hi everyone. Today we'll look at the mathematical relationship between acid-base pairs. This is a way to convert the acid equilibrium constant Ka into a base equilibrium constant, where the acid equilibrium constant applies to the acid in the reaction and the Kb for the conjugate base. We have this new formula where Kw equals Ka multiplied by Kb. Kw is a constant. It has a value of 1.0 times 10 to the power of negative 14. It's called the water autoionization constant. We don't need to memorize that. We can find it in the data booklet on page 3, where all of our other constants are. That's the place where we found specific heat capacities. It's the place where there's a unit conversion chart. It's page 3. We can find it right here. Kw 1.0 times 10 to the power of negative 14. This is a funny kind of question because the method that we're going to use to solve it is a calculation. It's a calculation style question. But when we read the question, there's not going to be any numbers in it. So it's incumbent upon us to go to the data booklet. It looks like this. What is the Kb for the conjugate base of benzoic acid? We're looking for Kb. This is going to turn into a calculation, but there aren't actually any numbers right in the question. So our first step is to think about this new calculation. Kw equals Ka times Kb. Kw equals Ka times Kb. This question specifically says, what is the Kb? We're looking for the base equilibrium constant, which is going to be Kb is Kw divided by Ka. That's the mathematical operation that we're going to do, just one step. But none of the numbers are in the question themselves. Kw, it's a constant. It's 1.0 times 10 to the power of negative 14. It doesn't have units. We don't need to memorize it. We can find it on page 3 of the data booklet. 1.0 times 10 to the power of negative 14. The Ka is benzoic acid. So we need to go to the acid-base table of the data booklet, which is on pages 8 and 9, and look up the Ka for benzoic acid. I found it. It's 6.3 times 10 to the power of negative 5. The calculation that we're going to perform, we had to look up both values. Now we can do the operation. 1 times 10 to the power of negative 14 divided by 6.3 to the power of negative 5. We get 1.587301587 times 10 to the power of negative 10. Okay. We need to think about our significant digits. The numbers that we used had 2 significant digits. Our answer, likewise, here, 1.6 times 10 to the power of negative 10. The base equilibrium constant doesn't have units, so we made it to the end of the question. This is a significant style of question, and it's a little bit funny because it's a calculation, but the question itself doesn't have any numbers in it. It's very doable. It's just another formula to remember. We're always going to look up the Kw. It's always going to be 1.0 times 10 to the power of negative 14. We can find it on page 3 of the data booklet if we need to refresh our memory. The Ka, we're going to find the acid in the acid-base table. Here, benzoic acid, I looked that number up. The calculation itself is pretty straightforward. Watch those significant digits, and there are no units for our equilibrium constants. And I hope that helps.